Hello everyone, welcome back to my YouTube channel. In this video, we will be covering the topic matter in our surroundings and we will be doing a quick revision on the topic. Now, what exactly is matter? Matter is defined as anything that occupies space and possesses mass. All the things which we see or feel around us, like air, water, plants, animals, stones, sand, ice, steel, etc., are termed as matter. They are made this matter is made up of particles known as molecules which have spaces between them and are continuously moving. They are very small and they also exert an attraction force on other molecules. Matter can be classified as into two types of classifications on two bases: physical classification and chemical classification. Physical classification is when matter is classified as solids, liquids, and gases, and chemical classification is when matter is classified as elements, compounds, and mixtures. Let us look at the concept of diffusion. The intermixing of particles of two different substances on their own is diffusion. The rate of diffusion increases on heating, since with increase in temperature, kinetic energy of the particles, also known as molecules, increase and they move faster. So therefore diffusion is slowest in solids because the particles do not move much, but diffusion is fastest in gases as particles move rapidly and can diffuse easily. This can be observed in an example of lighting an incense stick. The fragrance spreads quickly in the room when it is heated. This is due to the vapors of the incense stick getting mixed with the air and moving rapidly in the room. This is a common example of diffusion. The particles are in a continuous state of motion. Another example is when you mix crystals of copper sulfate with water. The water of the whole beaker will turn blue after some time. The spreading of the blue color is of the copper sulfate is due to the movement of particles of copper sulfate and movement of water particles, which is basically diffusion. The particles of copper sulfate get diffused into water. Let us look at the physical classification of matter. Matter is classified into three states: solids, liquids, and gases. Let us look at their properties. Solids have a fixed shape and fixed volume. Liquids have no fixed shape but they have a fixed volume. Gases have neither a fixed shape and neither a fixed nor a fixed volume. Both liquids and gases take the shape of the container. Now, solids cannot be compressed as they are very rigid. Liquids flow from a higher level to a lower level, but they cannot be compressed much. Gases, they flow very easily and therefore can be compressed easily and are highly compressible. The density of solids is high. Density of liquids is lower than that of solids but higher than that of gases. But the density of gases is very low. Now solids, they mostly don't diffuse as they have a high rigidity and they do not flow very easily. Liquids, they diffuse slowly as they are somewhat fluid. Gases, they can diffuse rapidly as they flow very easily and the particles move rapidly. The diffusion also depends on the kinetic energy of particles. In solids, the kinetic energy of particles is almost negligible and is very less. In liquids, the kinetic energy of particles is more than that of solids, and in gases, the kinetic energy of particles is very high, and therefore the particles in gases move rapidly. Now, there are two more states of matter, but they're only observed in some cases. The fourth one being plasma. This state can consist of super-energetic and super-excited particles. These particles are in the form of ionized gases and free electrons. A fluorescent light bulb or a neon sign bulb is an example of plasma state. The fifth state is the Bose-Einstein condensed state. This state is called the fifth state of matter and is a main work of the scientists Satyendra Nath Bose and Albert Einstein. It was done by cooling certain gases of extremely low density to a very low temperature, and this very low temperature is known as super low temperature. We've taken a look at the properties of each of the three states. Now let us look at the reason behind these. The particle mode of three states. The intermolecular distance, intermolecular force of attraction, and kinetic energy of particles, or also known as molecules, determine their state of matter. In solids, intermolecular forces are very large and intermolecular spaces are very small. The molecules can vibrate but cannot change their positions. Hence, they have definite shape and volume and are almost incompressible. In liquids, intermolecular forces are fairly less compared to solids, and intermolecular spaces are somewhat large. The molecules can change their position, hence, they can take the shape of the container and flow from higher level to lower level. In cases of gases, the intermolecular spaces are about 1,000 times more than the liquids, and intermolecular forces are of almost negligible magnitude. That means the intermolecular forces are very less magnitude, and therefore the molecules are free to move in any direction. Hence, gases have no definite shape or volume. The kinetic energy of molecules of gases is maximum. So, since the energy is maximum, they also move randomly at a very high speed. So, when the gas is placed in a container, the moving molecules hit the side of the vessel and exert pressure on the walls of the container. Rigidity and fluidity are both properties of matter. Rigid means inflexible. A solid is a rigid form of matter. Due to its rigidity, it has a tendency to maintain its shape when subjected to external force and hence does not require a container to keep it. Example, a brick or a log of wood. They are both solid forms of matter. Fluid is a material which can flow easily and requires a vessel to keep it. Therefore, fluidity is a property of material which can flow easily. A liquid is a fluid form of matter which takes the shape of a container, while a gas is a fluid form of matter which fills the entire container. Volume and density. The space occupied by a substance is known as volume. The SI unit of volume is cubic meter, which is meter cube, and the common unit is liter, which is represented by the letter L. The mass per unit volume of a substance is density. The formula is for density is mass by volume. Units of density are kg per meter cube or gram per centimeter cube. Let us look at temperature. Temperature is a physical quantity that expresses the degree of heat. There are three different scales used to measure temperature. Number one, the Celsius scale, which is represented as degree C, Fahrenheit scale, which is represented as degree F, and Kelvin scale, or also known as the absolute scale, which is represented with the letter K. The Celsius scale is taken, the freezing point of water is taken as 0 degrees Celsius and its boiling point is taken as 100 degrees Celsius. Now, on Fahrenheit scale, the freezing point of water is taken as 32 degree Fahrenheit and its boiling point is taken as 212 degree Fahrenheit. Celsius and Fahrenheit scales are related to each other by the relation Fahrenheit is equal to 9 by 5 into the Celsius magnitude plus 32. Now, Kelvin scale is the SI unit of temperature. Freezing point of water is taken as 273.15 Kelvin or 273 Kelvin approximately, and its boiling point is taken as 373 Kelvin. Celsius and Kelvin scales are related to each other by the relation Kelvin is equal to Celsius, the magnitude of Celsius, plus 273. Interconversion of states of matter can be achieved by changing temperature or pressure. Let's take a solid substance, ice for example, and increase the temperature. The melting point of ice is 0 degrees Celsius. When the temperature exceeds the melting point, the object starts to melt. In this case, ice becomes water. Now, the effect of pressure depends on the melting and boiling points of different substances. Now, in this case, when we are melting ice and we decrease pressure, the intermolecular forces weaken and the substance changes into liquid, which is water in this case. Now, the two factors determining interconversion of state of matter are temperature and pressure. When we increase the temperature of a solid and it becomes a liquid, that process is known as melting or fusion. But when we decrease the temperature of that liquid and it becomes a solid, the process is known as freezing. Now take a liquid, for example, water. When we increase the temperature to its boiling point, over time it starts to vaporize, that process is known as evaporation or vaporization, where the liquid becomes a gas. But on cooling the water vapor or the gas, it becomes a liquid. For example, when you keep a hot gas against hot water vapors against a cool surface, you can see water droplets on the cool surface. This is a process of condensation taking place, where the gas becomes a liquid on cooling. In some cases, solids can directly become a gas without undergoing the liquid state. This process is known as sublimation. And when the gas becomes a solid without undergoing the liquid state, it is known as deposition or desublimation. Let us take a look at endothermic and exothermic processes. Endothermic processes are where heat is absorbed and therefore the matter changes its state. For example, melting, evaporation, sublimation, boiling. Melting is where the process is a process where a solid changes into a liquid by absorbing heat. And similarly, in evaporation, the liquid changes into vapors by absorbing heat, and therefore the temperature also increases. Now, exothermic processes are where heat is evolved or given out. Example in freezing, condensation, and deposition, also known as desublimation. In freezing, when you cool the liquid to a solid, the heat is given out from the matter to its surroundings. Similarly, in condensation, when you cool a gas into a liquid, the heat is given out from the gas towards the surroundings, into the surroundings, making the gas turn into a liquid. Now, let us look at the concept of latent heat. The heat which is given to the system during a phase change and which is not used in raising the temperature is called latent heat. Latent means hidden. So the latent heat is used up in changing the state by breaking the intermolecular forces of attraction. That's why it's known as hidden heat, because this heat is used in breaking the intermolecular forces of attraction. So hence there is no increase in temperature till the state completely changes to the next state. Now there are two types of latent heat of fusion and latent heat of vaporization. Now, latent heat of fusion. Latent means hidden. Fusion means melting. So in other words, this means hidden heat of melting. So it's defined as the amount of heat energy required to change 1 kg of a solid into liquid at atmospheric pressure without any change in temperature at its melting point. The one example is the latent heat of fusion of ice is 3.34 into 10 to the power 5 joules per kg. So joules is basically a unit of energy. Okay, now latent heat of vaporization, which is the hidden heat of evaporation, the heat required to break the bonds of a liquid so it changes into gas. So it is defined as the amount of heat energy required to change 1 kg of a liquid into vapor at its boiling point, and there will be no change in its temperature. So while there is latent heat is being supplied to a liquid, there will be no, if you look in the graph, there will be no change in temperature until and unless the liquid fully changes into a gas. Now, one example of latent heat is latent heat of vaporization of water is 22 into 0.5 into 10 to the power 5 joules per kg. Thank you for watching my video, and I hope you understood this chapter. Please leave in the comments what other chapter video you would like me to make, and don't forget to like this video if you understood it, and consider subscribing as well. Thank you.